All right, so this is the day 6 notes. We're going to be doing something called partial fractions to solve for missing variables in an equation. We're going to use two different methods. The first method is called the equating coefficients method, and the second method is called the convenient values method. So we're going to do this first example using both methods. First, we're going to start off with the equating coefficients method. In either case, no matter what, we're going to start with the multiplication of the LCD. So LCD stands for least common denominator. So in this problem, my least common denominator is whatever makes up all of my denominators. So I can see that there's an x plus 3. I can see that there's an x minus 3. So that's going to be my LCD. So I'm going to multiply this whole equation by x minus 3 and x plus 3. And just to make it easier, I'm going to write these two binomials right next to each of my 3 fractions. Once I'm done with this, now I'm going to try to cancel things out of my equation. So if I have something in the numerator and denominator that are both the same, they're going to cancel out. So in this first fraction, the only thing that remains is x plus 9. In the second fraction, after I cross off the x plus 3, I am left with a times x minus 3. And in my third fraction, after I cross off the x minus 3, I am left with b times x plus 3. For method number 1, my plan is to equate the coefficients. And that means that any coefficients of x, x squared, a constant, x cubed, whatever terms I happen to have, I'm going to set them equal on both sides. So first step would be to distribute the a. So I'm going to write this as ax minus 3a plus bx plus 3b. And on the left side, all I'm going to do is bring down the x plus 9. So I'm going to look at all my terms that have x's in them. I've got an x, I have an ax, and I have a bx. So for this coefficient, the coefficient is 1, which means that a plus b has to equal 1. Then I'm going to look at my constant. I have constant of 9, and I have negative 3a and positive 3b. Those two terms, negative 3a and positive 3b, have to add up to 9. So now I have a system of equations. I have two equations, two variables. I just need to solve this. I'm going to multiply by 3. I think that's going to be the easiest thing to do. So I'll have 3 equals 3a plus 3b. In my bottom equation, I'm not going to do anything. I'll have 9 equals negative 3a plus 3b. And then I'm going to add them together. And when I add them together, I get 12 equals. And then negative 3a and positive 3a cancel out. And 3b plus 3b is 6b. Which means that when I divide both sides by 6, I get b equals 2. And then I need to go back and solve for a. So I've got 1 equals a plus b, and we now know that b equals 2. So if I subtract 2 from both sides, I get negative 1 equals a. And this problem asks to identify any and all values for a, b, and c, and d, but we only have a's and b's in this problem, so I'm done with that. All right, now we're going to redo the exact same problem, but this time we're going to use the convenient values method. So step number 1 would be to multiply by the LCD, which we did when we did method number 1. And then we ended up getting x plus 9 equals a times x minus 3 plus b times x plus 3. So we're going to start at this step. So what does it mean by convenient values? Well, it would be really convenient if I could substitute in a number for x and get x minus 3 or x plus 3 to cancel out. And the way that I'm going to cancel that out is if it equals 0. So one convenient value would be if I were to let x equal positive 3. So I'm going to substitute everywhere I see an x, I'm going to substitute the value 3. So I have 3 plus 9. I have a times 3 minus 3. And I have b times 3 plus 3. Now I'm going to simplify, and then you'll see why this is convenient. So 3 plus 9 is 12. A times 0 is just going to give me 0, so that's actually going to cancel out. That's going to be nothing. 3 plus 3 is 6, and then I've got 6b, so plus 6b over here, which means that 12 equals 6b, which means that when I divide by 6 on both sides, b equals 2. And now I'm going to do the same thing to solve for a. All right, this time my convenient value would be what would make this quantity equal to 0. So that would be -3. So I'm going to let x equal -3 this time. All right, so I've got -3 plus 9 equals a times -3 minus 3 plus b times -3 plus 3. All right, -3 plus 9 equals 6. -3 minus 3 is -6, so -6a. And then 3 plus -3 will be 0. So b times 0 over here, that's going to cancel out. And now my equation says 6 equals -6a. So if I divide both sides by -6, I get -1 equals a. So hopefully you notice that we got the exact same answers. B equals 2 and a equals -1. Now for any of these problems, you're only going to do one of the two methods. We just wanted to show you both methods for this first problem because it's easy enough to do. And for the remaining problems, you can just choose whichever method seems like the least complicated for the problem. Or if you prefer one method over the other, then you always do one method instead of the other. All right, so let's look at question 2. So no matter which method you're going to use, you're going to first multiply by the LCD. So we look at all of our denominators. We've got a 6x minus 1, 6x minus 1 squared, and another 6x minus 1 squared. So that will be my LCD, which is 6x minus 1 quantity squared. All right, so I want to multiply by that so that I can eliminate all of my fractions. So my first fraction had 6x minus 1 squared in the denominator, which will cancel out. So all I have left is 30x minus 17. Then for this a fraction, one of the 6x minus 1s will cancel out, but one will be left. Okay, so I just have a times 6x minus 1. And then for this b fraction, the entire denominator will cancel out. So all I'm left with is b. All right, you could do the convenient values method by substituting in x to be 1/6, but I like the equating the coefficients method, so I'm going to do that. So I would get 6ax minus a plus b equals 30x minus 17. So I have x's and constants, so this is my x. And so 30 must be equivalent to 6a, which means that a is equal to 5. And then the other one would be -17 has to equal -a plus b. And if a is 5, then -5 plus b equals -17, which is -12 equals b. So that's my final answer. All right, if you wanted to do the convenient values method, I would let x equal 1/6. That would eliminate the 6x minus 1. That would make that equal to 0. But then for the next step, you can just pick any value for x. Doesn't have to cancel anything out. You just pick any value that you want to substitute in for x, and then you'll be able to solve from there. Problem number 3. Remember, first thing you're going to do, no matter which method you select, you're going to multiply by the LCD, which in this case is x, and then x squared plus 2. All right, in this first fraction, the whole denominator will cancel out, so I'll be left with x minus 7. In the second one, the x's would cancel out, so I will be left with a times x squared plus 2. And in the third fraction, the binomial cancel out, but we're left with x times bx plus c. All right, so let's distribute. We have ax squared plus 2a plus bx squared plus cx. And then we need to look at what's on both sides of the equation. All right, for my x squared terms, I know that there is no x squareds on the left side, but on the right side we have an a plus a b. Right? So that has to be equal to the 0 x squared on the left side. So 0 has to equal a plus b. All right, for my linear terms, I have 1x equals cx. So c must be equal to 1. So that one was easy. And then if I look at the constant, that is equal to 2a equals negative 7, which means that a is equal to negative 7 over 2. And then I just need to go back and substitute negative 7 over 2 plus b equals 0. And so b is equal to positive 7 over 2. That's the end of that problem. All right, let's look at problem number 4. So again, first step would be, let's multiply by the LCD, which would be x squared plus 3 quantity squared. All right, in this first fraction, I'm going to get rid of the whole denominator, so it's x cubed plus 2x squared, and there's nothing to multiply it by. In the second fraction, I'm going to get rid of x squared plus 3, only one of them, so that means that one of those is left. That has to be multiplied by ax plus b. And then in the third one, the whole denominator cancels, and nothing is left at the top to be multiplied by the cx plus d. All right, so now I need to distribute. I will get ax to the third plus bx squared plus 3ax plus 3b plus cx plus d equals x cubed plus 2x squared. All right, so now I need to combine some like terms and compare my coefficients. All right, I have, this is the only x cubed, so I know that a has to be equal to 1. For my x squareds, I've got only 1, so that's 2 equals b. All right, for my x's, I've got 3a plus c. That equals no x's on the left side. I do know what a is, so 3 times 1 plus c has to equal 0, so c is equal to negative 3. And then for d and b, we have 3b plus d has to equal any constants on the left side, which is 0. All right, so now I'm going to substitute in 3 times 2 plus d equals 0, and d equals negative 6. All right, so let's take a look at number 5. Remember, we're always going to start with what is your LCD. This trinomial does not factor because nothing's going to multiply to 4 that adds to negative 2. So we're just going to have to include that trinomial as part of our LCD. So our LCD is x plus 2 times x squared minus 2x plus 4. And we're going to write that next to each of our fractions, and then we're going to cancel anything out and see what is left over. So when I look at each of my fractions in this first fraction, the x plus 2's cancel out, and the x squared minus 2x plus 4 cancels out, so I'm left with 2x squared minus 11x minus 6. In my second fraction, the x plus 2's cancel out, and I'm left with a times x squared minus 2x plus 4. And then in my third fraction, the trinomial cancels out, so I'm left with bx plus c times x plus 2. So be careful on this last one. The bx plus c has to be in parentheses because it's an entire binomial times the other binomial of x plus 2. All right, so let's try this with the convenient values method. There's going to be one very easy value to use, which would be x equals negative 2. So why is that helpful? Well, if we plug in negative 2 here, that gives us 0. So we're going to substitute in negative 2 everywhere we see an x, including on the left side. So we have 2 times negative 2 squared minus 11 times negative 2 minus 6 equals a times negative 2 squared minus 2 times negative 2 plus 4. And then we don't really have to show any work. We know that if we substitute in negative 2 there, it's going to be 0. And 0 times anything is going to cancel out. So that's gone. All right, so let's see what's left over. The only variable that remains is a, so we should be able to solve for a from here. So 2 times negative 2 squared is 2 times 4, which is 8. And then plus 22 minus 6, that'd be 30 minus 6, that's 24. So we have negative 2 squared, that's 4, plus negative 2 times negative 2, that's positive 4, plus another positive 4, that's 12. So we have 24 equals 12a, which means that a is equal to 2. All right, that gives us one of our answers that we're looking for. So now for our other convenient value, nothing's going to cancel out my trinomial entirely, So let's just pick an easy number. What's an easy number that we could plug in? Well, how about what if x were 0? All right, so let's substitute in 0 everywhere we see an x. So 2 times 0 squared minus 11 times 0 minus 6 equals a times 0 squared minus 2 times 0 plus 4 plus b times 0 plus c times 0 plus 2. All right, so now we just need to simplify and be careful simplifying. This becomes 0 minus 0, but then we have minus 6. And then we have 0 minus 0 plus 4. That becomes 4a. Then we have 0 times b. That cancels out, but the c is still there. And then we have 0 plus 2. That's 2. So we have 2c. So we have negative 6 equals 4a plus 2c. Now, remember that we already solved for a earlier, so we can use that in this equation. And we know that negative 6 equals 4 times 2 plus 2c. So we have negative 6 equals 8 plus 2c. And if I subtract 8 from both sides, I get negative 14 equals 2c, which means that c is equal to negative 7. All right, so now for the last thing, pick another easy number, 1 or negative 1. I would think that 1 is a little bit easier to substitute. So remember, I'm going back to this red equation over here and substituting in. So I'm going to let x equal positive 1, and we're going to see what happens. So 2 times 1 squared minus 11 times 1 minus 6 equals a times 1 squared minus 2 times 1 plus 4 plus we have b times 1 plus c times 1 plus 2. All right, so let's simplify it, and we'll be careful simplifying. So 2 times 1 squared is really 2 times 1, which is 2, minus 11, minus 6. So negative 9 minus 6 is negative 15, equals a times, we have 1 squared, which is 1, minus 2 plus 4. So that's going to give me negative 1 plus 4, which is 3. So let's call that 3a. And then we have b times 1, which is just b plus c, times 1 plus 2, which is 3. All right, so negative 15 equals 3a plus 3b plus 3c. If you want, you could divide everything by 3 to make the numbers easier, or you could just substitute in our values that we have for a and c. Let's just do that. So negative 15 equals 3 times 2. We don't know b yet. That's the one we're going to solve for now. Plus 3c, which is 3 times negative 7. So we have negative 15 equals 6 plus 3b minus 21. And if I do 6 minus 21, I get negative 15. And negative 15 equals negative 15 plus 3b. So if I add 15 to both sides, I get 0 equals 3b. And when I divide by 3, so the 0 divided by 3 is 0, and that gives us our final missing variable. So now we know values for A, B, and C. All right, that's all for these notes. Ask your teacher if you have any questions.